Today we're going to look at another example of applying stoichiometry. We've looked at solids and liquids and measuring them as grams for every 1 mole, the molar mass. We've looked at gases now and looked at measuring them in liters and looked at the volume for every 1 mole of gas. Now we're going to look finally at solutions, and we're going to look at how many moles are in a liter of solution. So again, like all the other examples, we're going to start by just reading the problem and figuring out what it's asking, and then getting into units of moles. So we have 65 milliliters of 1.4 molar silver nitrate solution. So I'm going to circle that. Was mixed with a 0.67 molar solution of iron 3 chloride. A double replacement reaction occurred, forming silver 1 chloride and iron 3 nitrate. What volume of iron 3 chloride was required? So I'm going to underline volume of iron 3 chloride because that's what it's asking me. Was required to completely react with the silver 1 nitrate solution. So we know how much silver nitrate we started with, and we want to know the volume of iron 3 chloride that we end up with. So as with every stoichiometry problem, first step is to get into moles of what we know. So we know silver nitrate, and we know that the silver nitrate has a molarity of 1.4 moles for every 1 liter. We also know that we have 65 milliliters, or 0.065 liters. And we want to know how many moles that is. So if you cross multiply, it tells us that in 65 milliliters of this solution there are 0.091 moles of silver nitrate. So I'm going to come put that in my BCA table here, and I want to know how much iron chloride is going to react, so that's kind of what I'm trying to figure out. I don't start with any products. So let's start filling out the change line. It says that the silver nitrate reacted completely, so we're going to use all of that up. There is a 3:1 ratio of silver nitrate to iron chloride. There's 1/3 as much iron chloride as silver nitrate, or 3 times as much silver nitrate. So I'm going to take my change line here and divide it by 3 to get the iron chloride. So I found out that 0.0303 moles of iron chloride must react. So I'm going to put that up here. I'm just going to assume all the iron chloride also reacted. To fill out the rest of the BCA table, there's a 3:3 or 1:1 mole ratio of silver nitrate to silver chloride. So because they have the same mole ratio, the change lines will be the same. And there is a 3:1 ratio of silver nitrate to iron nitrate. It's the same as the ratio between silver nitrate and iron chloride. So this guy's change line is 0.030. So do my arithmetic here. Nothing left. That's all been used up, and we've created 0.091 moles of silver chloride and created 0.030 moles of iron nitrate. Looking back to my problem to figure out what we want to know volume of iron 3 chloride. So I find my iron 3 chloride, and that's where I'm going to focus in my attention. We want to know how much was required to react. So that's this 0.030 moles here. But we want to know volume, not moles. Well, happily, we were given the molarity of the iron 3 chloride in our problem too. So again, we're going to just kind of go off to the side and do a calculation to get back into moles. Our iron chloride has a molarity of 0.67 moles in 1 liter. And according to our mole relationships, we have found 0.030 moles that reacted So we want to know how many liters. And so I'm going to take 0.030 divided by 0.67, and that gives me 0.045 liters. And there are 1,000 milliliters in 1 liter, so this is equal to 45 milliliters. So that is an example of stoichiometry by employing molarity.